All right, so where are we now? We have shown that any partition gives me an equivalence relation. We've also shown that functions give an equivalence relation, but that's kind of a side note for now. The question now is, if I have an equivalence relation, can I get a partition from it? All right. And in fact, the answer is yes. However, to get there, we have to introduce another notion, and that other notion is equivalence class. So in this section, we're going to be talking about equivalence classes. And it's really pretty straightforward from the definition of equivalence relation. So for instance, if we have the equivalence relation defined by given names, right? So in this example, we're looking at all the people in a certain population, and there's some people whose name is Mary, some people whose name is John, some people whose name is Sylvester or something else. Now, if I group all of the Johns into a single set, then that's a subset of the population. I can group all the Marys together into a single set. I can group all of the Sylvesters into a single set. Now, if I do that for all of the given names in the population, that's going to divide the set of all people up into subsets. In other words, it's going to create a partition. So what did I do? I started with a relation which was defined by first name or given name, and I created a partition from that by grouping together people who are related. Okay? So an equivalence class is simply a set of all elements in a larger set that are related. Formally, we can define it this way. We use square brackets to denote equivalence class, and we say that the equivalence class of an element little a in big A is the set of all elements in big A that are related to little a. Okay. So I can define this for an equivalence relation, and I developed the notion of equivalence class. Right? So here's another example here, similar to the previous one. Instead of we were saying first name, we've been saying given name, because in other countries they don't work it quite the same way. But in every culture they have a given name. Okay, sorry. All right. So, all right. So we can do this with names. We can do this with numbers. Let's see, what do we have here? So here we have another equivalence relation, and we can create equivalence classes from that. All right. Now we can prove the following facts about these equivalence classes. And you will do that in an exercise. First of all, you can prove that every element is contained in its own equivalence class. We can show that every equivalence class is non-empty. We can show that the union of equivalent classes is the entire set on which the equivalence relation is defined. We can show that any two elements that are related give rise to the same equivalence class, and we can show that any two elements that are not related belong to disjoint equivalence classes. All right? So you can see from here and from here, it sure seems like we're showing that these equivalence classes form a partition. And in fact, that's exactly what we're going to show. So here's the steps of the proof and some hints that you can follow. And I'm just going to go right into this subsection here, that in fact we will show that for any equivalence relation, if I consider the equivalence classes of that equivalence relation, those equivalence classes form a partition of the set on which the equivalence relation is defined. Okay. So you have here, for instance, you have an equivalence relation, and you have equivalence classes 1, 3, 4, and 2, 5. In other words, 1 is equivalent to 3, 3 is equivalent to 4, 1 is equivalent to 4, etc. 2 is equivalent to 5, 5 is equivalent to 2, and so on. But these two equivalence classes actually form a partition of the set on which the equivalence relation is defined. Some exercises for you to test this out. The upshot is that partitions and equivalence classes are really two different ways of looking at the same thing. You can break up a set into subsets, or you can define a relation on elements in the set, and that will break the set up into subsets. It's just two perspectives on the same basic situation. All right? So we'll stop there for this section.